we're going to show you is how to bring up an amplifier that you don't know, is unknown, so this particular one is just freshly built. So we're going to show you how to bring it up on a variac to normal working voltage. The working voltage in Europe is 230 volts. So we'll show you to bring that up slowly. In our second video we will show you how to test the frequency response from it, which is the roll off on the bass end and the high end, high frequencies. Normal frequency response is measured at -3 dB down, but for the sake of the video we'll also show you how to test the 0 dB line, which is the flat response curve. And in the third video we'll show you how to test the output power from this video. My name is Graham Holland, I'm the owner of Audion, and this is our 2011 intern Kieran. So once again we start on the basic procedure for powering up Audion Sterling EL34 Mk1 stereo tube amplifier. We've just built this one, so we don't know if it's going to work or not. We assume it will do, but we'll go through the basic procedure involved in setting the thing up, putting voltage onto it and checking to make sure that there are no problems. For this test we will use a very straightforward 0 to 270 volt variac, which delivers 2 amps out, an ammeter which shows us how much current the amp is drawing, and an oscilloscope just to make sure it's working. So we've set the amp up at the moment. It's been built, it's been visually tested. We have the volume control at the full. Now if you'd go ahead, Kieran, and connect up the cables. The setup we have at the moment is a pair of RCA cables going to a signal generator, which we use in a later episode. The loudspeaker terminals are connected to an 8 ohm dummy load. They're also connected to a millivolt meter, which is connected to the seat gen in this case, and also to the oscilloscope. So if you go ahead and continue to connect those up, Kieran, plug in the power cord and then switch on. At the moment we're at 0 volts on the variac, as you can see. Kieran has now connected the amp up. He will now switch on, and at present there are 0 volts, and as you can see from there, there are 0 amps being drawn. So if I can ask you to now connect up the multimeter, which you've done. The multimeter connects to the floating ground on the amplifier, and you'll see there are very basic volts there. We've got 0 volts. If you now wind that up to approximately 50 volts, Kieran, we'll see from the ammeter as well that there's still no current flowing, but we're now at the 50 volt mark. So if you perform the basic HT checks on there, you'll see now that we have approximately 120 volts on the HT supply. The 2 HT points on the EL34s are checked, and the 2 HT points on each of the input and driver tubes are checked. And you'll see there around about 120 volt mark, which is about right. So we can see from that so far that all is good. So if you increase now the voltage to approximately 100 volts, now we're sitting at the 100 volt mark, you'll start to see a small amount of movement on the ammeter, which is showing that we are drawing a little bit of current. If you go through the HT checkpoints again, same points as before, you will now see there are 230 volts approximately, 228, 230 volts approximately, and 160 reducing, which tells you that the capacitor is now charging up. And again on the lower points, 111 reducing, and 104 reducing. So we can see now the capacitors are charging up. So you'll see now there is a slight current draw, not a great deal, and still no signal. So if you increase now to approximately 100 and, let's say 140 volts, between 140 and 150, what you'll see now is the current will start to increase as we increase the voltage. So go to 150. You'll see now we're starting to get a small current draw, and you'll also see from the scope that we're starting to get signals. So that means this HT getting through into the amp, and the amp is starting to work. So you go through the HT points for us. You'll see we're now at the 300 volt mark roughly on the HT. HTB plus 297 300 volts approximately, and on the smaller tubes 130 reducing, so that means they're starting to work, and the test points on the other valve tube 106 volts, so they're starting to work as well. So if we look now at the scope, you'll see we have quite a good signal coming through now, and from our millivoltmeter output it's starting to show that we have output. So if you increase now the voltage to approximately 200 volts, in Europe, as I say, we use 230 volts, so it's not a problem. And you'll see from that we're now starting to draw around about half an ampere current, which tells me the amp is working quite well. You'll see we have a good balanced signal output from our millivoltmeter. You'll see there's a strong signal now. Now we check through the HT points. The HTB plus is now at 385. 385 on the right tube. The driver tube 165 and reasonably stable now. 163 and stable. 123 and 125. So it's pretty okay. Strong signal from the output. That's going to see there. If you bring it up now to final voltage of 230 volts. We normally test to 230 volts in Europe, but obviously for places like United Kingdom and Australia we need 240 volts and 245, but now you can see we're drawing approximately 0.6 amps of current. The signal hasn't changed obviously, and the test points now you'll see we're showing 438 on the left, 439 on the right, which shows we're pretty well balanced, 185 on the driver tube, 183 on the left side, and on the input tube 132 volts left and 135 volts right, so that's pretty good. So from there we can prove that the amp is now working. In the following video we'll show you how to check the frequency response, that's the roll off at 0 dB and -3 dB.